인터뷰 영상을 하나 준비했습니다. 파인만이라는 과학자 영상이죠. 수학 선생님이 과학자 영상을 보여준다고 어리둥절해할 필요 없습니다. 수학과 과학은 우리가 사는 세계를 설명한다는 부분에 있어서는 똑같으니까요. 아마 이 사람을 아는 사람도 있을 겁니다. 우리나라에서는 계산력이 컴퓨터보다 뛰어난 사람으로 유명하죠. 기차와 파리 문제로 우리나라에서 널리 알려진 사람입니다. 이 문제는 선생님이 작년 2학년 시험 때 조금 변형해서 냈었어요. 자, 여기까지 하고 이 영상을 보여주는 목적은 먼저 우리는 각자마다 공부하는 목적과 그 방법이 다 다릅니다. 대표적인 방법으로 그저 암기할 수도 있습니다. 이 방법은 단순히 엄청난 인내심과 암기력이 필요하죠. 어쩌면 엄청나게 많은 펜과 종이를 쓸 수도 있습니다. 이러한 방법이 나쁘다는 것은 아닙니다. 어떤 것을 하든 어느 정도의 암기는 필요하니까요. 그러나 선생님이 이야기하고 싶은 부분은 조금 다릅니다. 암기하는 방법 이외에 우리는 어떠한 학문을 탐구할 수도 있습니다. 내 수학적 수준에 맞추어서 끊임없이 왜라는 질문을 던지고 그 질문에 답하는 과정에서 어떠한 지식을 얻게 되는 거죠. 그리고 그 지식뿐만 아니라 지식들 사이의 관계망도 형성할 수 있습니다. 왜라는 질문을 하는 것도 그 질문에 답하는 과정도 쉽지 않습니다. 어쩌면 중간에 펜을 집어 던질 수도 있고 심지어 포기할 수도 있죠. 그러나 이러한 모든 과정을 겪게 되면 남들보다 조금 더디고 비효율적이진 몰라도 완벽한 나의 지식으로 만들 수 있습니다. 이러한 방법은 인내심도 필요하지만 이 방법을 수용하는 방법에 대한 어느 정도의 감이 필요합니다. 아, 이런 느낌이구나. 이런 걸 본인 스스로 느낄 수 있어야 하죠. 이런 걸 느끼게 하고 싶어서 선생님이 이 영상을 준비했습니다. 이 인터뷰 영상이 끝나면 수학에는 어떻게 적용을 해야 될까에 대한 설명도 있으니까 끝까지 봐주세요.
If you get hold of two magnets and you push them, you can feel this pushing between them. Turn it around the other way and they slam together. Now, what is it, the feeling between those two magnets?
What do you mean, what's the feeling between the two magnets?
There's something there, isn't there? I mean, the sensation is that there's something there when you push these two magnets together.
Listen to my question. What is the meaning when you say that there's a feeling? Of course you feel it. Now, what do you want to know?
What I want to know is what's going on between these two bits of metal.
Magnets repel each other.
And well, then what does that mean, or why are they doing that, or how are they doing it?
You're asking.
I must say, I think that's a perfectly reasonable question.
Of course,
to
it's a
ask.
reason. It's an excellent question. Okay. But the problem that you're asking, you see, when you ask why something happens, how does a person answer why something happens? For example, Aunt Minnie is in a hospital. Why? Because she went out and she slipped on the ice and broke her hip. That satisfies people. It satisfies, but it wouldn't satisfy someone who came from another planet, knew nothing about things. First, you should understand why, when you break your hip, do you go to the hospital? How do you get to the hospital when the hip was broken? Well, because her husband, seeing that the hip was broken, called the hospital up and sent somebody to get her. All that is understood by people. Now, when you explain a why, you have to be in some framework that you allow something to be true. Otherwise, you're perpetually asking why. Why did the husband call up the hospital? Because husband is interested in his wife's welfare. Not always. Some husbands aren't interested in their wife's welfare when they're drunk and they're angry. And so you begin to get a very interesting understanding of the world and all its complications. In order to if you try to follow anything up, you go deeper and deeper in various directions. For example, you could go, why did she slip on the ice? Well, ice is slippery. Everybody knows that, no problem. But you ask, why is ice slippery? That's kind of curious. Ice is extremely slippery. It's very interesting. You say, how does it work? You could either say, I'm satisfied that you've answered me, ice is slippery, that explains it. Or you could go on and say, why is ice slippery? And then you're involved with something, because there aren't many things as slippery as ice. It's very hard to get. Greasy stuff, but that's sort of wet and slimy. But a solid that's so slippery? Because it is in the case of ice that when you stand on it, they say, momentarily the pressure melts the ice a little bit, so you got a sort of instantaneous water surface on which you're slipping. Why on ice and not on other things? Because ice expands water expands when it freezes, so the pressure tries to undo the expansion and melts it. It's capable of melting it. But other substances contract when they're freezing, and when you push them, they're just satisfied to be solid. Why does water expand when it freezes and other substances don't expand when they freeze? All right? I'm not answering your question, but I'm telling you how difficult a why question is. You have to know what it is that you're permitted to understand and allowed to be understood and known, and what it is you're not. You'll notice in this example that the more I ask why, it gets interesting after a while. That's my idea, that the deeper a thing is, the more interesting it is. And we could even go further and say, why did she fall down when she slipped? That has to do with gravity, and involves in all the planets and everything else. Never mind. It goes on and on. Now, when you ask, for example, why two magnets repel, there are many different levels. It depends on whether you're a student of physics or an ordinary person who doesn't know anything or not. If you're somebody who doesn't know anything at all about it, all I can say is that there's a magnetic force that makes them repel, and that you're feeling that force. And you say, but that's very strange, because I don't feel kind of force like that in other circumstances. When you turn them the other way, they attract. There's a very analogous force, electrical force, which is the same kind of a question. And you say, that's also very weird. But you're not at all disturbed by the fact that when you put your hand on the chair, it pushes you back. But we found out by looking at it that that's the same force, as a matter of fact. The electrical force, not magnetic exactly in that case, but it's the same electrical repulsions that are involved in keeping your finger away from the chair, because everything's made out of its electrical forces in minor and microscopic details. There's other forces involved, but this is connected to electrical forces. It turns out that the magnetic and the electric force with which I wish to explain these things, this repulsion in the first place, is what ultimately is the deeper thing that we have to start, what we can start with, to explain many other things that looked like they were, everybody would just accept them. You know, you can't put your hand through the chair. That's taken for granted. But that you can't put your hand through the chair, when looked at more closely, why? That involves these same repulsive forces that appear in magnets. The situation you then have to explain is why in magnets it goes over a bigger distance than in ordinarily. And there it has to do with the fact that in iron, all the electrons are spinning in the same direction. They all get lined up, and they magnify the effect of the force until it's large enough at a distance that you can feel it. But it's a force which is present all the time and very common, and is in a basic force of almost, I mean, I can go a little further back if I were more technical, but at an early level, I just have to tell you that's going to be one of the things you'll just have to take as an element in the world, the existence of magnetic repulsion, or electrical attraction, magnetic attraction. I can't explain that attraction in terms of anything else that's familiar to you. For example, if we say the magnets attract like as if they were connected by rubber bands, I would be cheating you, because they're not connected by rubber bands. I shouldn't be in trouble. You'd soon ask me about the nature of the bands. And secondly, if you were curious enough, you'd ask me why rubber bands tend to pull back together again, and I would end up explaining that in terms of electrical forces, which are the very things that I'm trying to use the rubber bands to explain. So I have cheated very badly, you see. So I'm not going to be able to give you an answer to why magnets attract each other, except to tell you that they do, and to tell you that that's one of the elements in the world of different kinds of forces. There are electrical forces, magnetic forces, gravitational forces, and others, and those are some of the parts. If you were a student, you'd go further. I could go further. I could tell you that the magnetic forces are related to the electrical forces very intimately, that our relationship between the gravity forces and electrical forces remains unknown, and so on. But I really can't do a good job, any job, of explaining magnetic force in terms of something else that you're more familiar with, because I don't understand it in terms of anything else that you're more familiar with.
영상 잘 봤나요? 그렇다면 이제 이 방법을 통해서 우리가 수학 공부를 어떻게 할 수 있는지 대해서 잠깐 설명해 보도록 하겠습니다. 우린 1단원에서 어떤 기하 분수의 분모에 소인수가 2 또는 5뿐이면 이 기하 분수는 유한소수로 나타낼 수 있다라는 어떤 수학적 사실을 알게 되었습니다. 그런데 이 수학적 사실을 아무런 고민 없이 그냥 암기하고 받아들일 수도 있지만, 그와는 다르게 왜 2 또는 5뿐이면 이게 요한소수로 나타낼 수 있을까라는 질문을 던질 수도 있고, 혹은 분모의 소인수가 2, 5가 아닌 3인 경우는 어떻게 될까? 7인 경우에는 11인 경우에는 어떻게 되지? 라는 질문을 던져볼 수 있습니다. 이러한 문제를 해결하기 위해서 우리는 몇 개의 나눗셈을 진행할 겁니다. 3분의 1이나 7분의 1을 할 수도 있고 7분의 3을 할 수도 있겠죠. 하다가 관찰을 통해서 우리는 다음과 같은 사실을 알 수가 있습니다. 아, 나누는 수보다 항상 작은 수들만이 나머지로 나오는구나. 즉 7로 나누게 되면 그 나머지는 0부터 6까지 총 7개밖에 없습니다. 그렇다면 나눗셈이 계속 진행이 된다면 그 7개 안에서만 나오기 때문에 어떤 특정한 패턴이 반복됨을 알 수가 있습니다. 그러면 그 다음은 이런 게 문제겠죠? 왜 나머지는 나누는 수보다 작은 수만 나올까? 그에 대한 해답은 나눗셈을 하는 방법에 있겠죠. 자, 이런 식의 공부 방법은 시험 공부랑은 거리가 멀어 보입니다. 상당히 비효율적인 것처럼 보이죠. 그러나 여러분들이 조금이나마 특정 부분이나마 이러한 공부 방법을 통해서 공부를 하다 보면 수학을 하는 재미를 느끼고 과학을 하는 재미를 느끼고 수학과 과학이 왜 필요한지에 대한 해답을 찾을 수 있다고 생각합니다. 그래서 선생님은 이 방법을 조금이라도 해보기를 추천합니다. 자, 그럼 여기까지 하겠습니다. 안녕, 다음에 봐요.